All right, welcome back. Today we're going to be traveling through time to explore the history of artificial intelligence.
Oh, cool.
Whether you're brushing up for a big presentation or just curious about how we got to self-driving cars and AI art generators,
hmm
this one's for you.
It's interesting you should mention self-driving cars and AI art because those seemingly futuristic applications have roots going back decades.
Ah,
AI's history is full of twists and
yeah.
turns, moments of great promise, followed by periods where progress just seemed to stall.
Okay, so where does this winding road
Yeah.
begin?
Yeah.
When did people start dreaming of machines that could think?
Well, you could argue that the dream goes back centuries,
Mhm.
but the real groundwork for AI was laid with the invention of the electronic computer in the 1940s.
Okay,
This was the technological springboard that made everything else possible.
gotcha.
In fact, one of the earliest examples of a machine designed to mimic intelligent behavior comes just a few years later, in 1950.
Oh, tell me more. What kind of machine are we talking about?
It was called Theseus, and it was a robotic mouse created by Claude Shannon.
A robotic mouse.
Yeah.
That's kind of adorable.
Yeah.
What did it actually do?
Theseus was designed to navigate a maze.
Okay.
It was a simple concept, but it illustrated the possibility of machines learning and solving problems,
Hmm.
even if in a very rudimentary way.
So from robotic mice in mazes to the complex AI systems we have today, what were some of the major leaps forward?
Well, the 1950s and 60s were a period of incredible excitement and innovation in AI research. We begin to see the emergence of key figures like Herbert Simon, Alan Newell, and J. Clifford Shaw,
Okay.
who developed groundbreaking programs like the logic theory machine at the Rand
The
Corporation.
logic theory machine.
Yeah.
That sounds pretty serious.
It is.
What was so special about it?
Well, until that point, proving complex mathematical theorems was considered the domain of brilliant human minds. But the logic theory machine was designed to do just that, and it did it remarkably well. It actually managed to prove 38 theorems from Principia Mathematica, a landmark work in mathematical logic.
So a computer was basically doing advanced math on its own.
Yeah,
That must have caused quite a stir back then.
it absolutely did.
Yeah.
People started to realize that machines could potentially tackle intellectual tasks that were once thought to be exclusive to humans.
Right?
And then in 1956, a pivotal event took place.
Okay.
The Dartmouth Summer Research Project on Artificial Intelligence. This workshop is considered the official birth of AI as a field. It was here that the term artificial intelligence was coined by John McCarthy.
So this was like the big bang of AI research,
Exactly.
bringing together all the pioneers.
Yeah, and at this workshop, researchers were already exploring a range of approaches to creating AI, including symbolic reasoning, neural networks, and machine learning. It was a real melting pot of ideas,
Wow.
with researchers tackling the fundamental question of how to replicate human intelligence in machines.
Were there any particular approaches that gained traction early on?
Yeah, one prominent approach was known as heuristic programming.
Okay.
Instead of trying to program every possible scenario, researchers developed sets of rules or guidelines that AI systems could use to solve problems.
Okay.
Think of it like giving the machine a set of strategies to try out.
Okay, so it was about giving the machines some uh, some problem-solving tools rather than trying to anticipate every move.
Right.
Did this approach prove to be successful?
It had its successes, but it also had limitations.
Mhm.
AI research in those early decades was a roller coaster ride of progress and setbacks. There were periods known as AI winters,
Oh, yeah.
where funding dried up and enthusiasm reigned
Really?
because certain approaches didn't live up to their initial hype.
Why did that happen? What caused these fluctuations in interest in funding?
Well, one factor was the limitations of computing power.
Right.
AI research relies heavily on powerful computers to process information and run complex algorithms. In those early days, computers were simply not powerful enough to handle the demands of some of the more ambitious AI projects.
So progress in AI was tied to advancements in computer hardware.
Absolutely. The development of faster and more powerful computers was essential for pushing the boundaries of what AI could achieve.
Yeah.
It's like trying to run a demanding video game on a slow, outdated computer. You need the right hardware to unlock the full potential.
That makes sense.
Well,
So as computers became more powerful, did the approaches to AI research evolve as well?
they did. One of the most significant shifts came with the rise of machine learning.
Yeah.
This approach moved away from explicitly programming every rule and instead focused on allowing machines to learn from data.
Ah, this sounds like where things start to get really interesting.
Yeah.
How does machine learning work exactly?
Essentially, you feed a machine learning algorithm massive amounts of data, and it learns to identify patterns and make predictions based on that data.
Right.
It's a fundamentally different approach from trying to program every possible outcome.
So it's about letting the machines figure things out on their own based on the information they're given.
Right.
Did this shift to machine learning lead to any major breakthroughs?
It absolutely did.
Ooh.
The availability of vast amounts of data combined with the advancements in computing power created a perfect storm for machine learning to flourish.
Wow.
We started to see incredible breakthroughs in areas like image recognition, natural language processing, and even game playing.
This feels like the lead up to the AI boom we're experiencing now,
Yeah.
with things like AI art generators and self-driving cars becoming more prevalent. Is that where things are headed?
You could say that.
Yeah.
This shift to machine learning marked a turning point in AI research. It opened up a whole new realm of possibilities and set the stage for the rapid advancements we're seeing today.
Wow, what a journey it's been.
I know.
We've covered a lot of ground in a short amount of time, from those early robotic mice to the rise of machine learning.
And we're only just scratching the surface.
Oh, wow.
The history of AI is a testament to human ingenuity and our relentless pursuit of understanding intelligence itself.
It's definitely been a fascinating trip through time so far. But I'm curious to know more about those breakthroughs you mentioned.
Yeah.
What were some of the key milestones that really pushed the boundaries of AI?
Well, one of the early milestones that really captured the public's imagination was Deep Blue's victory over Garry Kasparov in 1997.
Oh, yeah, the chess match.
Yeah,
That was a huge deal, wasn't it? I remember watching it on TV. It felt like a turning point.
it was a landmark event.
Yeah.
Deep Blue, a chess-playing computer developed by IBM, defeated Kasparov, the reigning world chess champion, in a 6-game match. It was a stunning demonstration of the progress that had been made in AI, particularly in the areas of brute force computation and strategic decision-making.
It must have been a real blow to human pride,
Yeah.
having a machine outsmart the best chess player in the world.
It certainly shook things up. Some people saw it as a sign that machines were on the verge of surpassing human intelligence in all areas. But others argued that Deep Blue was simply a very specialized program that excelled at one particular task. It wasn't truly intelligent in the broader sense.
So it sparked a debate about the nature of intelligence itself.
Exactly. And that debate continues to this day.
Right.
What does it really mean for a machine to be intelligent?
Right.
Can a machine that can beat a grandmaster at chess also understand a joke, write a poem, or empathize with another human being?
Those are some pretty deep questions.
Yeah.
So Deep Blue was a big step, but what came next?
Yeah.
What were some of the other areas where AI started to make significant strides?
Well, one area that saw remarkable progress was natural language processing.
Okay.
NLP for short.
LP.
This field focuses on enabling computers to understand and process human language.
So we're talking about things like language translation,
Yes.
text summarization, and even chatbot assistants.
Exactly. Early NLP systems were quite limited, but with the advent of machine learning and the availability of massive text data sets, things really started to take off.
Okay.
Google Translate, for example, became a much more powerful and accurate tool,
Right.
thanks to the use of machine learning algorithms that could learn from millions of translated sentences.
That makes sense. The more data you feed these algorithms, the better they get at understanding and processing language.
Yeah.
What about other areas like computer vision? Did that field also benefit from the machine learning revolution?
Absolutely. Computer vision focuses on enabling computers to see and interpret images and videos. And again, machine learning played a crucial role in advancing this field.
So we're talking about things like facial recognition software,
Yes.
self-driving cars that can navigate roads,
Duh.
and even medical imaging systems that can help doctors diagnose diseases.
Precisely. Those are all examples of applications that rely heavily on computer vision.
Okay.
And the progress in recent years has been remarkable.
Yeah.
For instance, facial recognition software is now used in everything from unlocking your phone to identifying suspects in criminal investigations. And self-driving cars are becoming increasingly sophisticated in their ability to perceive and respond to their surroundings.
It's pretty mind-blowing to think about how far we've come. From a robotic mouse navigating a maze to self-driving cars cruising down the highway, it's been quite a journey.
It really has, and the pace of innovation continues to accelerate.
Hmm.
One of the most exciting areas of research today is deep learning, a subfield of machine learning that involves training artificial neural networks with multiple layers.
Deep learning, that sounds intriguing. How is it different from traditional machine learning?
Deep learning models are inspired by the structure of the human brain,
Okay.
with interconnected layers of artificial neurons that process information. These models can learn complex patterns and representations from vast amounts of data,
Right.
and they've achieved groundbreaking results in areas like image recognition, speech recognition, and natural language understanding.
So it's like giving machines a more sophisticated way to learn and process information.
Exactly.
Yeah.
Deep learning has been the driving force behind many of the recent breakthroughs in AI,
Yeah.
such as the development of AI art generators that can create stunningly realistic images from text prompts or language models that can generate human-quality text in a variety of styles and formats.
It sounds like we're entering a whole new era of AI capabilities.
Mhm.
Are there any particular applications of deep learning that you find particularly exciting or promising?
One area that's particularly fascinating is the use of deep learning in scientific research.
Okay.
For example, deep learning models are being used to analyze astronomical data, predict protein structures, and accelerate drug discovery.
Wow, so it's not just about consumer applications like chatbots or art generators.
Right.
Deep learning is being used to tackle some of the biggest challenges facing humanity.
Absolutely. The potential of deep learning to advance scientific knowledge and solve real-world problems is immense, and we're only just beginning to explore the possibilities.
This has been an incredible overview of the history of AI.
Yeah.
It's amazing to see how far we've come, and it's exciting to think about where we might be headed.
It's a field that's constantly evolving and pushing the boundaries of what we thought was possible.
But with all these advancements, there must also be challenges and limitations. What are some of the hurdles that AI researchers are still grappling with today?
You're right, there are still significant challenges. One of the biggest hurdles is the issue of explainability. Deep learning models can be incredibly complex with millions or even billions of parameters, and it's often difficult to understand why a particular model makes a specific decision.
So it's kind of like a black box. We know it works, but we don't fully understand how.
Exactly, and this lack of explainability can be a problem, especially in areas where trust and transparency are crucial, such as healthcare or finance.
That makes sense. If an AI system is making decisions that affect people's lives, we need to be able to understand its reasoning. What are some other limitations of current AI systems?
Another challenge is generalization. Many AI systems are trained on specific data sets and can perform well on tasks that are similar to those they were trained on, but they often struggle when faced with new or unexpected situations.
So they lack the flexibility and adaptability of human intelligence.
That's one way to put it. Humans are remarkably good at generalizing knowledge and skills to new contexts. AI systems are still catching up in that regard.
It sounds like there's still a lot of work to be done before we achieve the kind of artificial general intelligence we see in science fiction movies.
That's right. AGI, or artificial general intelligence, remains a long-term goal for AI research. We're still a long way from creating machines that possess the same level of cognitive abilities as humans.
But despite these challenges, there's a sense of optimism and excitement surrounding AI. What are you most looking forward to in the future of AI?
Well, I'm excited about the potential of AI to augment human capabilities and solve some of the world's most pressing problems. Imagine AI systems that can help us address climate change, develop new medical treatments, or personalize education to meet the needs of every learner.
It's inspiring to think about how AI could be used for good. But as AI becomes more powerful, it also raises ethical concerns. How do we ensure that AI is developed and used responsibly?
That's a crucial question. We need to have thoughtful conversations about the ethical implications of AI and develop guidelines and regulations that promote fairness, transparency, and accountability.
So it's not just about the technical advancements, but also about the societal impact and ensuring that AI benefits humanity as a whole.
Exactly. The future of AI is not predetermined. It's up to us to shape it in a way that aligns with our values and aspirations.
This has been an incredible journey through the history and future of AI. I feel like I've gained a new appreciation for the complexity and potential of this transformative technology. Thanks for joining me.
It was my pleasure. AI is a fascinating field, and it's been great to share some insights with you and your listeners today.
It's a field that's full of surprises, challenges, and endless possibilities. And for our listeners, keep those questions coming. The future of AI is being written right now, and we all have a role to play in shaping it. Until next time, keep exploring.